Hi guys, I'm back. So last time we had a look at how to make this motor run more safely, and this time we'll focus on creating the frame that's going to hold the motor in place. Oh my god, what happened here? So many tools. Let's clean up the mess. So I sort of made these DXF files from the 3D drawing of the frame, and so I printed them and cut them out. So here's the first one, and it came out pretty nice. My girlfriend bought me this Dremel for our anniversary, and it helped out a little bit, but it doesn't cut all the way through easily. So basically for the finer details I still had to use the handsaw, like in this area here for example, and also to use a file for example for the details like on the outside here. So here's the second one, and I didn't actually finish this, but it was also made on a piece of HPL that was slightly too small. So like I was trying to save material, but basically that got me cut in the finger. Kind of annoying. So what's the plan? I decided that it would be nice to work on the CNC machine again. So this motor that I've been misusing as a generator motor, it sort of was the milling motor of this CNC machine, and it definitely does not have the cutting power that I need for this project. Now I do have this better milling motor, and I bought it specifically to customize this CNC. It's a AMB 1050 FME1. It's a super awesome milling motor. However, now we need to sort of fit it onto this CNC machine. So the first time I tried to create something to hold the motor in place, I sort of made it eyeballing a little bit. It fits, but it wiggles, and sort of had to use a lot of tape to get it to stay stable. But just having that, I was able to mill something, and it's not the most strong material, but it was possible to mill it. And I figured out the 3D drawing was off by a couple of millimeters, so I had to file it further. It's also wiggly. We sort of only have to cut through this high pressure laminate. It's quite a strong material and it has to plunge, so the motor has to be held in place quite firmly. So I sort of used the other pieces as a template for this next piece that I'm cutting out. It also wiggles, but it's a little bit less, and I think that if we put the pieces together they might sort of clamp fit it and it might work. So here we are looking at the new iteration of the CNC. I sort of got it together, and yeah, well, I had to file here and there because it didn't fit all at once. And as you can see, there's still some wiggle room, but it's a lot less than it was previously. Yeah, if you're gonna move it from here, that's going to make it wiggle even more. But since the arm of force is going to come from here, I think we're okay. It's just a little. And I think it only matters when the CNC plunges, it sort of get pushed up, right? So here we are looking at Fusion 360, and I sort of copied the sketch of the frame to another document. So to make code for the CNC mill, we go into this tab here and select manufacturer. As you can see, I set up the stock to have a centimeter on each side of the drawing basically. In order to cut out this model, we sort of want to select the 2D contour, and then it will generate a path for the tool to go by. So what's important to select with the 2D contour is the maximum roughing step down. I selected it to be 0.5 millimeter so that we don't get too much pressure on the mill. As for the drill size, we're using a 3 millimeter flat end, and I've selected it in this as well. As you can see, the simulation looks promising. So you can either select setup here or the 2D contour and go to post process, and it will export the file. As you can see, I'm using GRBL, which is the program I'm using. So here's the program that I'm using to mill. It's called GRBL Control, and as you can see, we can now zoom in and look at the passes that it's going to make. As you can see, the reference axis here is on the bottom of the material. So in real life, we sort of want to zero the z-axis on the green material here, and so we do. As for the x and y axis, I zeroed it in somewhere in the middle here. So now we can look if there is enough material, and so we can scroll around the model. So I'm following the trace here, and as you can see here, in reality we're sort of on the edge. Also, when looking at the top here, we can see that the mill is already on the edge again, and it sort of wants to cut this sort of outline, but I decided maybe if we can swap the model over like that, then we'll have enough material. So let's go ahead and do that. Right, so I made another G-code and I calibrated the model, and let's start milling. So as you can see, the milling is done, and I think that the bed is a little bit slanted, so you can see it's cut all the way through over there, but not here. And somehow it went a little bit off course along halfway somewhere, and it somehow picked it up again. So there may be still some tuning to do, but this thing cuts the material a lot faster than I can without cutting into my fingers. So in order to cut out the edges here, I think we can use this Dremel. So here we are, the piece is out, and I had to do some filing. But all in all, this is a very quick method of making this thing. So the thing that's a little bit strange about this is that when you look at the original and put it on top, you see that there is a little bit more material here lengthwise. But I don't think that is our biggest problem here. So that's it for now, and I hope you enjoyed watching this video, and if you like it, please subscribe and press the like button. And thanks for watching, see you next time!